Well, good morning, guys. What happened to our nice weather? We were warming up, and today when we walked, why, it was 13 degrees out with the wind chill, gave it down to about -2. So, when the shop's no warmer, it doesn't seem like. So, we are in the house this afternoon or this morning, and we decided we better lay out a little gear blank for this 127 tooth metric gear. And what I think I'm going to do is we're just going to draw it up in Fusion very quickly, and then I'll probably send it over to the 3D printer and just print out a pattern for this. Is going to be the easiest way for me to do it. So I'm basically duplicating a Sheldon gear, and I've got to check and see if this is the same pitch and pressure angle as on the Atlas. I've got a couple of gears here that I'll measure later, but I'm not going to worry about that today. I do have a gear cutter in for at least this 127 tooth, so we'll proceed with this project. But I pulled a few dimensions off of some of my other Sheldon gears and figured out what they are, and I've already done most of the math. Now, a lot of guys are going to the machinist handbook for dimensions, and I've got a machinist handbook here on the shelf. It's not the one that I normally go to for stuff like this. What I use is I've got an old Odell's Machinist Handbook, or it's Machinist and Toolmaker's Handy Book is what they call it. This one's dated 1941, and this was evidently a Navy issue book to some sailor. It's got a couple of names on the inside of it, and a ship's name, but it's got initials stamped all over it, all through, for S.E. Hill, which is interesting because that's my last name, but as far as I know, I'm no relation to this. I found this in a used bookstore years and years ago, and it's on just about every edge, and there's probably 75 or 100 places inside the book that it's stamped with the same stamp. So somebody wanted to make sure it was theirs, and now it's been passed on to me, and I'm sure generations from mine now, if it continues to be passed along, they're going to say, oh, this was Grandpa's or great-grandpa's book, when, it actually didn't start out as my book at all. Anyway, I've already done some calculations and stuff. What I ended up with, and I've seen a couple of different thread pitches and pressure angles for the Sheldon lathes, depending on, I think, when they were produced. Didn't really take any of it to heart since there's so many variations on it, so I measured a couple of my Sheldon gears, and it ends up these are a 16 pitch with a 20-degree pressure angle. And mine are EXL machines, both the same and everything. But anyway, that's what they measure out to be. So, and I don't have the math here in front of me, but checked them both ways, and that's definitely what I've got. So I've already done the math for the 127 tooth gear, 16 pitch, 20 pressure angle. I want a 127 tooth gear. So the math is you take your number of gear teeth, which is 127, you add 2 to it, which gives us 129, and you divide that by the pitch. So 129 divided by 16 gives me a 8.0625, and that's going to be the outer diameter of my gear. So what I'm going to do is I'm going to add a little machining allowances all the way around on this gear, just so I make sure I've got enough when I cast them, and then we'll go from there. Now, I'm going to cast this out of aluminum because for the amount of work that this is going to see, that I'm actually going to use a metric gearing on it. I think aluminum will last fine, and Atlas gears are made out of Zamac. For some of the replacement gears that guys have been making for on the Sheldons have been out of Bakelite and things like that. So we'll see if it holds up. If it doesn't, why, we'll do something else. But anyway, this is proof of concept. So quick and easy, we'll cast a blank out of aluminum once the weather warms up a little bit, and we'll go from there. So that's what we got for math. So basic dimensions of my Sheldon hub, and we're just going to draw this up in Fusion as we go. These are, we're going to go with a sketch with diameters first. We've got we want, 8.0625, so let's go 8.375 for an outer diameter, just to give us lots of room. Now these are going to have a 1/2-inch bore, but I'm going to leave them blanked out. When I cast these, I'll pour directly into the bore on it, which is going to have a hub too. So we'll do that. Inner hub diameter is 1.25 inches, and we can pretty much stay with that. 1.250. There's our inner hub diameter. This gear is going to be a 1/2 inch wide when we get that far. We're going to do, what are we going to do here? We're going to pattern this up as a one-piece gear rather than doing a split pattern on this. We'll just do one tooth. It'll actually be for the 1 or 2 that we're going to cast out of these. That will be plenty. So we've got an OD. We're going to have a inner circle on the inside of these gear teeth. The gear that I measured shows about a 1/2 inch in between. So if we want an 8-inch gear, let's do a 7-inch inner, and that will give us the inner little boss we've got, and then our teeth will run around this edge, you know, at whatever distance they end up being. And then we have, and we're going to model them in here just to use a little less material and to make it more realistic. We've got 6 1-inch diameter holes around the outside. So we're going to do a construction line, C for circle, at 1.25 inch diameter. We've got a 7 3.5. If we go about 3 inches, no, 5 is going to be too much. What's 4 give us? All this stuff's just in the air. We can always change it. Okay, so if we do a 4.5 inch construction circle, and if we create a circular pattern, so you're gonna, oh, we have to put a starting point on here. And if we just do a point there, actually we don't need to do that at all. We can do a circle right there. Come on, there we go. And we do a 1-inch diameter circle. And then we do a pattern. Of those circle. Okay, that looks pretty good. So now if we let's extrude this, and we're going to add a little extra material here. I think, well, we've got a 1/2 inch. Let's do it's actually in the cast iron, it's only about 1/8 of an inch thick. Let's do let's do symmetric. Distance, let's do 30 seconds. Should give us 1/8 of an inch, or 3/16 of an inch. So we're going to do that. And let's get these sketches back up here. We want to extrude our yeah, we'll do 3/16 in the bore. We want a 1/2 inch. So let's go same thing. Symmetric distance. Let's go 5/8 by 2. Now what we should be doing, yeah, we're not going to add any draft angle to this. Let's see how this looks. And then let's go this way. We want to repeat and extrude. We actually want a little more material there because we've got a hub, and I think we actually only need it on the one outer side, but that's okay. I think we're going to put it both ways. And we've got material to cut off on both the outer edges. What happens if we add a 2-degree taper to that? What happens if we add a -2-degree taper to that? To these top and bottom. Ooh. Good. Let's add those same. Let's add a fairly substantial fillet there, 20 thousandths. Do the same thing here. Oh, that's not going to work. We've added that taper there. We'll have to go back and change that. That. Let's flip her over and do the same thing. Now all we're doing is just adding fillets here. We'll change this around when we get that far. 15,000 is probably okay for that. Same way with this. There, and can we add one more right here? We can't. It's because we put draft there. Yeah, if we wouldn't have added draft there, we could have put a fillet there. I'm sure there's a way to correct it, but I'm not going to worry about it a whole lot. And actually, that's all we need to do. Okay, so let's turn off all those sketches and see how that looks to us. So that should give us a gear blank that we can use. I think that's actually all we need. I mean, this is quick and simple. There's guys that are a whole lot better at fusion than I am that will go in and say, yep, do this, do this, do this. If I would not have, oh, I guess we didn't add a chamfer there. Except we don't want a chamfer, we want to fill it. And I think, you know, for quick and dirty, that's all there is to this. I'll take and export this over to Cura so I can put it on the 3D printer, and we'll print one of these out and see what it looks like. So anyway, I'll leave this right here. That's what we got for you. Lots of projects going on once we get back out in the shop. I've been working on some of the projects I've already mentioned, got quite a bit of video shot, but we'll get those out here, like I say, as soon as the weather clears and I finish up some of these projects. So anyway, hopefully you find this a little bit useful. Comment suggestions, leave them in the comment section for me below. And as always, guys, thanks for taking the time to watch.